Good evening and once again welcome to my YouTube channel Pearson at Excel International Maths, and we continue to explain topic number 1 in Pure Mathematics 2 Algebraic methods. And today and in this video I want to explain example 12 and example 13. And in example 12 you're told to prove that if x minus p is a factor of fx, then fp is equals to 0. That is what we are supposed to prove. And of course we know it goes without saying that if we divide fx divided by x minus p, we are going to get another function of x. That we know, just like the way we would divide 8 over 2 to get a 4. So in this the same format, if we cross multiply, we're going to find 8 is equals to 2 times 4. And in the same way, fx here is equals to the divisor x minus p multiplied by the other quotient which we got after dividing. So if this is true, then if we would want to talk about fp in the same kind of language and frequency, we're going to say fp is going to be, every time we come across x, we substitute with p, is going to be p minus p multiplied by the g of x. And of course, it goes without saying that fp is equals to 0 times the quotient that was realized, which is just 0. So therefore fp is equals to 0. And it has been proven that is exactly what we wanted to show. But here is what you need to understand, that if you divide a function with a divisor, of course you get a quotient that is another smaller function of x. When you cross multiply, you find gx is equals to x minus p, which is a divisor, multiplied by the quotient. And that is just like that. Hence shown. We have been able to prove that fp is equals to 0. In the same video, let us explain example 13. Let's just explain example 13. And in example 13, we're told to prove that A 1 1 1 1, B 3 3, and C 4 2. This is turning out to be a triangle. Are vertices. They are vertices of a right angled triangle. They are vertices of a right angled triangle. There are two approaches in this one. You can construct accurately in the XY Cartesian plane using a graph paper, and of course you would be able to measure that angle. One of the angles of the triangle is supposed to be 90 degrees. But we can prove this algebraically, and of course using the approach of the gradient. Let me just assume we are having the XY Cartesian plane here so that we can discuss about it. If we say this is 1 1 and this is point A, there is point B 1 2 3, we could have a 3 there, and 3 3 there, it could be point B 3 3, and point C 4 2 4 2, somewhere there, 4 2, that is point C. So we have that line, we have that line, and that line. So we are supposed to prove that these are vertices of a right angled triangle. And follow me to talk about the gradient of AB. The gradient of AB is the change in y over the change in x. That means 3 minus 1, 2 over 3 minus 1, 2, which is 1. Let's get the gradient of BC, which is the change in y. It's going to be 3 minus 2, which is 1, over 3 minus 4, which is negative 1, which is basically negative 1. And even before we go further, we could even get the gradient of AC, assuming that we have not seen this one, but we are going back to this because our explanation lies in the product of the two. Change in y over the change in x. 2 minus 1 is 1. 4 minus 1 is a 3. If you look at the two gradient, 1 times negative 1 is equals to negative 1. And we know that now that the product of the gradient of AB and that of BC is negative 1, is actually negative 1, then the two lines are perpendicular. The gradient of AB is 1. The gradient of BC is negative 1. Then the two lines are perpendicular, meaning that they meet at right angle. And that is all we needed to show or to prove. All right.